Welcome back to Learning Journal. As promised earlier, in this video, I am going to talk about Apache Spark and Apache Cassandra connectivity. But before that, you might want to understand the use cases that require connecting Spark and Cassandra. So, let's start with understanding the main strengths of Apache Cassandra. Apache Cassandra is an open source, distributed and NoSQL database, right? Apache Cassandra offers linear scalability, high availability, fault tolerance, and high-speed read-write performance. The read-write performance over a huge volume is the most distinguishing feature of Cassandra as a database. Despite being a NoSQL database, it supports a query language that is similar to SQL. That makes Cassandra easy to learn. Cassandra offers replication across multiple data centers and cloud availability zones. That's another powerful feature. That means you can serve your global customer requests from their nearest data center. Cassandra data model is more suitable for large, denormalized tables that we designed to support a group of known queries. That means if you have a requirement where you need to create huge tables, a table to store hundreds of gigabytes or even terabytes, and then you want to fire a set of known queries on them, Cassandra is a great choice. However, there is a downside of Cassandra data model. You don't get relational features and ACID transactions. But you can solve many big data requirements without those relational features. In summary, Cassandra is a good choice for two categories of use cases. Big data OLTP systems. These are the systems that require a high-speed write performance and does not require relational features and ACID compliant transactions. Serving layer of big data platforms. These are the systems that require a big data reporting layer for a known set of queries that we can serve using denormalized tables. So, if you have any of these big data use cases, you might need to implement read-write to Cassandra database. How to connect Apache Spark with Cassandra? That's what I'm going to demonstrate. I'll need a Cassandra cluster for that demonstration. Let's install a 3-node Cassandra cluster in Google Cloud. Follow these steps. Start your GCP console. Go to the Cloud Launcher. Search for Cassandra. You might see a bunch of options, but I prefer to use the one that is marked as Google Click to Deploy. Your Cassandra usage is free, but Google will charge you for the CPU, memory and disk space. But that's fine, I'm using my free credits. Click to the Launch button. You might want to change the zone to the same zone that you are using to create your Spark machine. I use the same zone to reduce the network latency. Different zones are in different data centers, and any communication between two different zones will experience unnecessary network latency. You might also want to choose a smaller machine type and reduce the default disk space. I don't need that many resources for my demo, right? Finally, click the Deploy button. That's it. GCP will provision your 3-node Cassandra cluster in less than a minute. You can SSH to one of the Cassandra nodes from the Deployment Manager page. Alternatively, you can jump to your Compute Engine instance page and SSH to one of the Cassandra nodes. Great! We are now ready to use Cassandra. Before we start connecting to Cassandra, I want to clarify two things about Cassandra database. Cassandra has the concept of a key space, which is similar to a database in relational databases. A key space is a level where we define data partitioning and replication strategy. So, I don't recommend creating a key space on the fly. Cassandra data model design is a conscious decision that completely depends upon the queries that you want to execute on that table. So, I don't recommend creating Cassandra tables on the fly. Most of the time, you will create a Cassandra table and populate the data from Spark. Great. Connect to Cassandra using the SQL/sh client. Execute a SQL statement to test if Cassandra cluster is up and running. Create a key space using below SQL command. Create a Cassandra table. Test the table. Great. Now you are ready to jump to our Apache Spark machine and try to connect Cassandra and load some data into this table. Start Spark shell and add Cassandra connector package dependency to your class path. I am using the latest connector as on date. The latest version of Spark uses Scala 2.11 and hence I am using the connector for Scala 2.11. The next step is to create a data frame that holds some data. Then we can write that data frame to a Cassandra table. Let's create a data frame. Use following code to create a data frame. You already understand this code, right? We used it in the earlier videos. If you look at the final data frame, the schema of my data frame complies with the schema of the target Cassandra table. That's a critical requirement. You might face a lot of issues if both the schemas are not the same. You can use the below code to save the data frame to Cassandra. The code is similar to what we have been using in this tutorial. Specify the format as Cassandra. You can use the overwrite mode, but you also have to confirm the truncation. You must specify your Cassandra host, port, key space, and the target table name. That's it. Execute the save method and your data moves to Cassandra. You can go back to your SQL client and verify the data load. If you think that specifying Cassandra host and port for every table write operation is not a good thing to do, you can specify these settings at the Spark session level. Use the below code. Once you set these settings at the session level, you can save the data frame without these settings. You can test it using the following code. In fact, you can pass these configurations from the command line as well using --conf option. There is no need to hardcode the connection parameters in your program. Reading from Cassandra table is again as simple as reading from any other data source. You can use the following code to test the read operation. Great! That completes the Cassandra connector demonstration. However, Cassandra is a powerful database. It offers features and various other configuration opportunities. It may not be possible to cover all of those things here. However, you can refer to the Cassandra connector documentation. It is freely available on GitHub. You can reach out to the main connector page here. You can get a list of general Cassandra configurations here. You can get a list of data frame configurations and a bunch of other examples here. Other than standard data frame APIs, the Cassandra connector offers a bunch of other shortcut APIs and utility methods. If you are interested, you can find those as well in the documentation. Great! Thank you very much for watching Learning Journal. Keep learning and keep growing.